when I made this video, like, I made so many mistakes on the computing it that, you know, I had to calculate it, and then I had to go back and edit it, and I had to do it again. And I just was reported to me that yet another mistake in it, and so I've cut out the whole middle part and I've replaced it with this part now. And I was hoping to be able to pull up my old video and just edit it, but then I deleted all of my old videos on September 18th, and I made this video on September 16th. So if I had made it just a few days later, I would have had it. But okay, so let me tell you, pick up where I left off. So we had our RLC circuit, and we had resistor up here that was 0.5 ohms, and we had a resistor here that was 0.2, and we had an inductor that was 4 millihenries, and we had a capacitor that was 2 microfarads. And I had just said that we needed to find the parallel impedance, which would be 1 over ZR plus 1 over ZL plus 1 over ZC. And so that would be 1 over 0.2 plus 1 over J omega L plus 1 over minus J over omega C. And so that's the same as 1 over 0.2, that's 1 over 1/5, so 1 over that is 5, plus 1 over, well, 1 over J is the same as having minus J in the numerator, so I'll put minus J in the numerator. I don't know if I showed this before, but 1 over J, if I multiply that by J over J, you get J over J squared. J squared is minus 1, so J over minus 1, which is minus J. So that'd be J over omega times 0.004 plus, now 1 over something makes it the reciprocal, so that'll be omega C over minus J. So this is 1 over 5, and then negative 1 over 0.004 is 250. So this is minus J 250 over omega. And then the capacitance was 2 microfarads. And if 1 over J is minus J in the numerator, then 1 over minus J is plus J in the numerator. So this is J omega times 2 times 10 to the negative 6. And so that are those 3 elements in parallel. And now if we add all of those to our 0.5 ohm resistor, we'd have 0.5 plus 1 over 5 minus J 250 over omega plus J omega 2 times 10 to the negative 6. I don't like that complex fraction, so I'll multiply by omega over omega, and I get 0.5 plus 1 over 5 minus J 250 plus J, the omega's canceled, that's why I did that, but I needed to multiply an omega here. So 5 times omega is omega, J over 250 times omega is J 250, and then this last one, J omega squared, 2 times 10 to the negative 6, and when I multiply the numerator, I get an omega up there. Okay, now I need to get a common denominator, so this will be 0.5 times 5 omega plus 250 plus omega squared times 2 times 10 to the minus 6 J. I just factored the J out of that part. We'll see why in a minute. So that gives us the common denominator of 5 omega plus 250, that's a minus 250. I made that mistake when I was rehearsing this. Plus omega squared times 2 times 10 to the negative 6 j plus omega over 5 omega plus negative 250 plus omega squared times 2 times 10 to the negative 6 j. Okay, so now when I add these, I'll go ahead and multiply this 0.5 through, and I get 0.25 omega plus negative 125 plus omega squared times 1 times 10 to the negative 6 j. So that was distributing this 0.5. And I'm adding all that to this, so plus omega over 5 omega plus negative 250 plus omega times 2 times 10 to the negative 6 j. Now, my goal is to figure out what omega makes the imaginary part of this equal to 0. And so to do that, I need to have all my imaginary stuff in the numerator. To do that, I'm going to multiply by the conjugate of the denominator. So then I get 5 omega minus negative 250 plus omega times 2 times 10 to the negative 6 j over 5 omega minus negative 250 plus omega times 2 times 10 to the negative 6 j. Okay, so the whole point of that is it gets rid of the imaginary part of the denominator. On this side, I have some like terms here. I have a 0.25 omega and an omega. So I have a 1.25 omega plus negative 125 plus omega squared times 1 times 10 to the minus 6 j. I have that times 5 omega minus negative 250 plus omega times 2 times 10 to the negative 6 j. And all of that is going to be over something real. So what it is, we don't need to calculate it, but it would be 25 omega squared, so it's the first thing squared plus the second thing squared. And that's what that is. But since that part is real, it cannot make our denominator, it cannot, if I want to figure out what makes the imaginary part equal to 0, a denominator cannot make anything equal to 0, only a numerator can make things equal to 0, and so I can ignore the denominator part entirely. So I can now just ignore this part and look at the numerator. And I don't have to look at all of the numerator, I just have to look at the imaginary parts, because I want the imaginary parts to be equal to 0. So what will get me imaginary parts when I do this multiplication? When I multiply the 1.25 omega times this, that will be imaginary. And when I multiply the 5 omega times this, that will be imaginary. But when I multiply the 1.25 omega times the 5 omega, that's real. And when I multiply this, that j should be on the outside, when I multiply that imaginary number times that imaginary number, j squared is negative 1, and so it's no longer imaginary. So when I multiply this, the 1.25, I get oh, there was a part that there was another omega in here, I think. Hold on. No, that part hadn't happened yet. So, I will have 1.25 omega times a negative, I'll put the negative right here, negative 250 plus omega times 2 times 10 to the negative 6. I'm a little worried about my signs. I feel like I've made a mistake with signs somewhere. And then this part, the other part would be plus 5 omega times negative 125 plus omega squared times 1 times 10 to the negative 6. I haven't written the j's because they all have j's, because this is the part that I want to set equal to 0. Okay, so now I could divide through by omega, and I am losing a solution there, but the solution I'm losing is omega equals 0, and that is not a resonant frequency. That's trivial. That's our trivial resonant frequency. So now when I distribute this, I get 312.5 minus 0.0000, I think it's 5 zeros, 1, 2, 3, 4, 5, 25 omega squared, minus 625 plus 5 times 10 to the negative 6 omega squared, and that equals 0. And then this gets me, if I combine my omega squareds, I get 0.0000. Hold on. Yeah, that works. So negative 0.00025 omega squared plus 5 times 10 to the negative 6 omega squared equals 0.00025 omega squared, and then 312.5 minus 625, add those together, bring them to the other side, and you get 312.5, and this gives us omega squared equals 125, 1, 2, 3, 1, 2, 3, take the square root, and I get omega squared equals omega equals 11.11180 radians per second, which amazingly is what I got the other time, even though I made a mistake with it, a big mistake, and somehow the mistakes all canceled out and I still got the right answer. And then that is the resonant frequency, and if that's the resonant angular frequency, and remember omega equals 2 pi f, and so if I have 11.180 radians per second equals 2 pi f, then if I divide that by 2 pi, I believe I get a frequency of 1779 hertz. So that's the resonant frequency. Okay, so I'm going to stop this and hopefully be able to insert it over the part where I had the mistake in the other one.